Hey, welcome to the 23rd lesson on C++. During this lesson, we will explore the topic of function templates in the C++ programming language. To understand the topic of function templates, I suggest first creating a simple program without using function templates. Later, we will enhance this program to understand what function templates are, why they are necessary, and where they can be applied. Let's write a program. Our program will be quite simple, containing only one function. Through this function, we will display an array on the screen. The function will be named print_arr, and it will take two parameters, a pointer to the first element of the array and the total number of elements in the array. Now, let's write a loop that will iterate from 0 to the number of elements in the array. Inside the loop, we'll have only one line of code. Therefore, I won't use curly braces. In this line, we'll use the standard output function, access our array, and add the variable I to it. To shift the pointer each time, we'll wrap the expression in parentheses and perform dereferencing. Initially, in the first iteration, there will be no shift as we add 0. In the second iteration, the variable will be 1, and so on. I won't add a new line after each element, instead, I'll just output a space. After printing the entire array, I'll add a new line. Now, in the main function, let's create an array called arr1 and initialize it with some values. After filling the array, I'll simply call the print_arr function, passing our array and the length of the array. In my case, there are 6 elements, so I pass this number. Let's try running the program and ensure that all elements of our array are displayed nicely on the screen. Now, let's consider a situation where I have another array. This time, the array will have a data type of float, and it will contain specific elements. If I want to display this array on the screen, the previous function won't be suitable, and an error will occur. This is logical because in the function, I specify the data type as integer, and I'm trying to pass a float data type to the function. Without the concept of function templates, the solution to this problem would involve using function overloading. I would need to change the data type in the function to float, and no errors would occur. However, the problem now is that if I want to display other arrays, say a string array or a character array, I would have to copy the function each time and change the data type. The issue with this approach is that I end up duplicating a lot of code just for a single data type change, which is not optimal. To address this problem, we can use function templates. Function templates allow us to write a generic function that can work with different data types without duplicating code. A function template is a function where you can not only pass parameters but also specify the data type to be used within the function itself. Instead of duplicating this function, I'll use the template keyword above the function. In the angle brackets here, I need to specify the parameters I want to receive in this function template. I only need to receive one data type here, so I use type name and a parameter name, which I'll pass here. The name can be anything, but usually, T is used here. Now, our function has become a template. I pass the data type I just created to this function. Instead of the int data type, I simply use the letter T. Thus, I will accept an array of pointers of a certain data type that will be passed. Now, when calling these functions, we can pass the data type. If you don't pass it, it is usually automatically substituted. Let's run the program and make sure everything works exactly as intended. However, it's better to explicitly specify the data type to pass, as the program currently decides which data type to pass. It's better to write this explicitly. To do this, after the function name, we need to put angle brackets, and inside them, we write the required data type. That is, I'm now specifying that when calling the first function, I'll pass the integer data type. And in the second function, I'll specify that I'll pass the float data type. If we run the program now, we'll see that all our arrays work without any problems. Again, the convenience is that I can create as many as 10 different arrays that can have different data types, but at the same time, the same function can handle all subsequent arrays. It's also worth adding that in template functions, you can include not only one but several data types. For instance, right now, I'm accepting only one parameter, t, but I can also write type name followed by a new name, separated by a comma. Thus, you can use as many data types as needed and work with them accordingly. Well, there you have it, that's the topic of function templates. Truly, it's a very useful feature with which you can tackle various problems. Our lesson has come to an end, and if you enjoyed it, don't forget to subscribe to the channel to stay updated with new videos. Thanks to everyone for watching, and until next time.